Hello everyone, I'm Vishesh Vaibhav, your Google Developer Student Club team. So this video is another video in the regression series where we are going to talk about multiple linear regression. So in the previous video, we talked about simple linear regression, which was a detailed explanation about what regression really is and how it really works. Now, this video will be a step up, and we are not going to dive into the many intricacies of regression, but instead, we are going to start out with a little bit of theory about multiple linear regression, and then we'll be jumping on to the practical part where we'll be implementing it. So, here I need you all to be very, interested in this thing because here we need you to apply your own mind at the end of this video, and let's see how you do it. So we started out just now, but before we start out, let me tell you what multiple linear regression really is. So as we talked about simple linear regression, multiple linear regression is just different from simple linear regression because it uses more than one independent variables. Now, what does that mean? Well, let us jump onto the theory and understand just that. All right. Okay, so now that we're here, let us understand what we did in our previous previous video. That was simple linear regression. So in simple linear regression, we had one dependent variable and one independent variable, which means I'll just recall what dependent variable and independent variables are. So dependent variable is what we are predicting. So it can be anything. So in this case, with X kgs of fertilizer, how many tons of potato we are getting. So here the dependent variable is potato because that is what we are predicting, and independent variable is what we are using to predict the predictor. That means the prediction we are what we are using to make the prediction, which is potato, right? So dependent variable is what we predict, and independent variable is what we use to predict. So the value that we use to predict, right? So here we use an example of potatoes yielded based on a fertilizer. So the only difference between simple linear regression and multiple linear regression is that multiple linear regression uses one dependent variable because that means that we are only going to predict one thing. So that the prediction is only going to happen on one column, and and we can have as many independent variables as we can. So using the same example as we did before, the potatoes yielded based on fertilizer, we can see that it predicts the value of y based on multiple values of x. So in this case, y was potato. So just let us just visualize it here. So if the potatoes yielded is y, the weather would be x1, the temperature would be x2, and fertilizer would be x3. Now, the potatoes yielded are dependent on weather plus temperature plus the fertilizer. Now, it's just not dependent on fertilizer alone. So this is what it gives us. Now, if we were to look back at the formula that we use for simple linear regression, it was y hat is equals to bo plus b1 x1, right? Now that was for one variable when we had one independent variable. Now we have many independent variables, this should change a bit, right? So this would still be y hat is equals to b0, which is a constant. So constant is nothing but the values that are unaccounted for. So there would be times where we'll be running into values which are unaccounted. For example, when we have string values in our data set, how do we have our string values in our data set, and how do we actually put string values into formulas? That is not really possible. That is why we use encoding, which if you remember we did in our data preprocessing toolkit. So yes, it is some values are just not accounted for in the formula or in the process with where we are calculating these things, but those values which are not accounted for is accounted for in constant. So you do not need to worry about this, you just need to know what formula that we are using. So it's b0 plus b1 x1 plus b2 x2 plus b3 x3, and this would go on for bn xn. All right, sounds good. This is, let me just write it really well. B3X3. This would go on for BNXL. All right. Still not a great handwriting, but I hope you understand. Okay. So this is what the formula for multiple linear regression is. So this is what you needed to understand multiple linear regression. So if you have a basic understanding of what is happening here, the only difference between simple linear regression and multiple linear regression is the dependent variables, independent variables. So dependent variable is going to be the same in both. We'll only have one dependent variable, but independent variable values changes. So in back there, were using only one independent variable, but here we can have as many as we want. There is no cap on how many independent variables we can use, but yes, there is a cap on dependent variable because uh, the prediction can only happen on one column. All right, so this is what it was, and now we are going to switch to our practical part because all right, so that should be enough to get us started and get us ready to understand our practicality. Because now that you have understood simple linear regression, all other forms of regressions should be pretty easy to you. Now we have visualized. So here you need to apply your uh, into intuition a little bit more because in at the end of the video you'll be doing some things which will not tell you, but you'll have to do it on your own, apply your own mind and do it. Let's see how you do. So that is what we are going to do right now. So I'll just fire up my laptop and let's see how we are going to do this. Okay, let me just bring it here. Okay, so the data set that we'll be using in this is actually a very great data set. So I'll be checking if the video is working or not because last time it did not work for me. So I'll be checking in between. Okay, so this is the data set that we are using right now. So what is this data set all about? Well, this is a data set of 50 startups. So as you can see, there are 50 startups, and this is actually a real life example if you look at it. So we have some R&D spends, some administration spends, some marketing spends, and the state. So the New York, California, and Florida, and then we have the profit they're making. Now, this is how you will have to think about this. So a venture capitalist firm has approached you, and as a data scientist, what you need to do is you need to create a model, some model that helps the VC firm or the venture capitalist firm decide which company they should invest in. Their main motto is the profit column. They want to know that which company should give me more profit. Now, mind you that this data is like categorically like or sorted profit wise. So the most profit this company is making, it's right here. So we do not know which company is what. We do not know the name of the company. What the venture capitalist firm is looking from you is that this R&D spend, this administration, and this marketing spend, they want to know that the combination of these. So for example, if some company is uh, uh, spending this much and this much on administration and this much on marketing, and it is from a New York state, this is how much this profit is what they are making. But what if some other company in New York is spending this much on R&D, this much on administration, and this much on marketing? Does the profit differ? So what what you think on the top of your head is, well, I have these profits with me, and these profits are sorted descending order. So this is the most profit uh, that a company is making, right? Now you might think that that is the case, but that is not what the company or the venture capitalist firm needs from you. It needs you to create a model where if they put some if they give some value of R&D, some value of administration, and some value of marketing spend, and any of these three states, then what is the profit they should be getting? So here your dependent variable would be the profit because that is what you want to predict. And what will be your independent variable? Well, all these four would be your independent variable. So I hope you get what I'm trying to say here. These four would help you predict the profit. So an R&D spend of this much, an administration spend of this much, and marketing spend of this much, and a state of New York contributes to a profit of this much, right? Sounds fair, but this is what the firm needs from you. It needs to create it needs you to create a model which would help them put in a value of all of these independent variables, and you give them a profit, some type of a model like this. So how do we do that? Well, we have most of the things that we need. We have the data set, we have our independent variables, and we have our dependent variables. So let us now start and build this from scratch, right? Because we have done that for simple linear regression, we're going to do the same for multiple linear regression. So how to do that? So first of all, we are always we are going to refer to our data pre-processing toolkit, which we made in our previous video. So you haven't watched this, you need to watch this in order to get the link to this is also in the description of that video. All right. So first of all, what we are going to do is we are going to import the libraries. Let us do that, importing the libraries. Importing the libraries, I am just going to move it here. All right, I'm just going to copy it. Most of the steps which are there would be the same. So I have just pasted it here. It is initializing, okay. And then meanwhile it's initializing, I'll copy this and I'll paste it. But before that, I'll add a new section which is importing the data set. All right, so I'll just bring it here. Now I'll upload the data set now. It's uploaded, and I'll copy the path and I'll paste it in. Okay, this would be different now. Now in the independent variable, if I were to visualize this, we have R&D spend, administration, and marketing spend. So and state as well. Just copy this and I'm going to paste it here. All right. And in the dependent variable, we have profit. So this is going to be the same. Now let us look at our data. Okay. So if we look at our data right now, the dependent variable is what we talked about. What we need to predict is profit. So is our dependent variable last one, last index? Remember, this is all we have talked about in our data processing video. So I'm just going to make it fast. So -1 means the last index. So is our dependent variable the last index? Yes, it is. So this is not going to change. And are all of this before the last index? Yes. So nothing to change here. We're just going to run this. Okay, sounds good. Now what we are going to do is we are going to print X and we are going to print Y. All right, so now we have this. Now what's the next step? Taking care of missing data. Now because it's a long data, it's a very huge data. It's not very huge, but still 50. The last one was 30, this is 50. So if I were just to visualize, am I seeing any NANs, not a numbers? I'm not saying it. Now, here is some zeros, but zero is a number. In this term, zero is a number. So this is not an empty value. We are looking for empty values or not a numbers. I do not see any not a numbers, which means this is ready to go. But if you still want to be sure, you can just go ahead and you can just make sure there are no missing data, right? Just to be sure of it. When there are large data sets, you cannot actually visualize it. You need to take care of missing data and you would go ahead with this step, but mostly we should not. Now, encoding categorical data. Now, remember why we did this. So encoding was done because in the last example, in the data pre-processing ones, we had some text data, which is string data, which is not parsable by our machine learning model. So for that, we need to convert into these kind of values. So if I were to recap what this actually means was these are some categories. So France is a category, Spain is a category, and Germany are the categories. Now, what it did was it created some categories for us. So wherever there was France, it is one, and wherever there are other values, it is zero. So as you can see, France, they're all ones, and the others are zero. So what it does is for every category, it's creating a column of its own. So it's like this, and this. So this is the column for France. This might be the column for Germany, and this is the column for Spain. You can check and you can understand why. So I'll give an example why, because see, France was the first year and France is 1 year, and all of the uh values are zero, but just the France is one. Now let us do that for the other one. So the third value is one, which means the Germany. So all values for Germany are one, and other values are zero. Even France and Spain are zero. Now same for the which one is left? Spain is left. So this all the values for Spain are one, and other values are zero. So this is what encoding categorical data means. Different it creates a different column for every category that we have. Now, if you remember which step was this, this was one hot encoding, if you remember that. So that is what we are going to do right now. We are going to encode categorical data. So I'll just write encoding categorical data, right? That is what we need right now. That is the need of the hour. We need to encode categorical data. So I just copy this and then I'll paste this. Okay, let us look at it. Okay, let us look at it now. Okay, so in the encoding, all of this would be the same. We are using the one-hot encoder and everything. They're all the same. Now, what do we need here? What do we need to change here? So I need you to pause the video and tell me. Just like think, not tell me, just think. What is that one thing that we need to change here? All right, so I'll tell you now. So remember in the previous one where we were using this, the first column was a string value or a text column, because of which we wrote zero here, which was the index of that column. Now, if we look at it here, all right, let me just plug that in so that I think it should work well, but I'll plug that in. All right, everything is good. I'll just check back again if everything is good or not. Okay. So that was the index back there. So if we look at this data, what is the index that we are looking for? 0, 1, 2, and 3, right? That is the index that we are looking for. So we'll write 3 here, and everything else would be the same. We do not need to change anything. Print x. And is there anything in the y that is string value? No, I do not think so. So this would just be print x, right? So you might be thinking, why this was the last column in X, right? Now, why did this change and come to the first? Now, whenever we are using one-hot encoding, the encoded value comes to the first of the column. So there were three categories, that is California, New York, and Florida, because of which we had three columns now. We have three columns now. If we had more, then there would be more columns. So it would always come to the first of the column that we are using. So in X, we have the first three columns now. Now you can check which one is which. So the first one is the column for California. You can check. And how do I know that? Well, the same logic that I used for this. Okay, so you can deduce the fact how did it happen. But yes, it's pretty straightforward. If you have watched our previous videos, then you should understand what this was. Okay, now we have printed X. Now what's the next thing that we need to do? Let us go into our toolkit. So do we need to encode dependent variable? No, because as I told you, no yes and no values or nothing like that as such. Now we need to split the data into training set and test set. So we're gonna do that, just that. Let me do that right here. Split data into training set and test set. Okay, well, we check if everything is working. Okay. So we're going to split the data into training set and test set. So nothing different, just copy and paste. So we just did that and everything is okay. We'll just paste this, run this. Okay. Now when this is done, let us look back into our linear regression model. What did we do after this? Well, we trained the data on the simple linear regression was there. Now we are training into multiple linear regression. Uh, and what did we do to know that which library are we using? Well, the same thing. Which sklearn library for multiple regression model? Okay, it's the same one then. So we are using the same linear regression model. So it's linear regression, right? The regression isn't changing. The type is changing where we are having multiple independent variables. So this is going to be the same. So I am just going to write from sklearn dot linear model import linear regression. All right, sounds good. Now, what's the next thing that we need to do? What we did, if you just go back to our previous notebook that we were using, well, there was nothing, but we created an object. So that is what we'll be doing. We'll be creating an object of linear regression. And we are not going to put anything here. We are going to use the default values like we did in the previous lecture. So, right, it's not defined. Have I made a mistake here? Yes, no, it's good. So it's regressor equal to linear regress. So what we are doing is we have created an object and we are using the class. Now this class would use the same, the default values of everything. We are not changing anything. Okay. And now what we need to do, we need to fit it. So regressive fit, right? Exactly the same thing that we are using, X train and Y train. Okay. Sounds good. Now you might ask that we in simple linear regression model we had only one dependent variable and independent variable and we use the same thing, right? Regressor dot fit exchange and right, but in multiple linear regression, why are we doing the same thing? Why are we not using anything different? Well, for the simple reason that it is still a linear regression model that is not changing. And in the regressor dot fit it asks us for the x and the y values, right? X is the X is what? Let us check what is X. The independent variables. So it can be independent variable, a single variable, or many variables. It depends on our data set. So that is what we are giving it. We are giving it the independent variables and Y train. What does it have? Well, Y train has nothing but the dependent variables, the exact values that we want to predict. So I hadn't printed X train, Y train. If you can do that after this and you can check everything. So I haven't printed it X train, Y train, X test and Y test, but you can do that or after this I'll just do it. So if I just go ahead and run this, this would have given us this. This is okay then. It's working. The linear regression model has been trained. Now for the visualization purpose, I'll just print X train and I'll also print Y train. I also print uh, X test. I also print X Y test. So I've just printed it for our visualization purposes. Okay. Everything is good now. Nothing seems different. Now you might be thinking, why did we not imply feature scaling? So the reason is in multiple linear regression, we do not used to use in any multiple linear regression, mostly we do not used to use feature scaling because these are something that we do not need comparing. Here we can just use these values, and we can make sure that the multiple linear regression, the sklearn library does that for us. So no need to apply feature scaling explicitly here. Although in multiple linear regression you don't need that. In some other models you would need that. We'll be discussing it later. All right, so I check everything is working. Everything is working. Okay. So the work for that is done, and we have now trained the model as well. Okay, now that is definitely done. So what we'll do is we'll make a prediction now. Now this is the most important part. That is, we are predicting the test set. Now, in the previous lecture, what we did was we visualized it. We are not going to visualize this time because you are going to do that, and you are going to use the things that the knowledge that we gained in the previous lecture, and you're going to help us visualize everything. And then, if you would be kind enough to put the um the screenshots of your visualization into the group, I'd be very happy because this is what I live for. So it would be predicting test set results. All right, this sounds good. Going to remove this. Okay, we are going to predict the test set results now. So I'm going to use the same thing that we did in the previous one, and this regressor.predict would back then I remember we did x train. No, we did x. We gave it x test. So if we just give it x test, it's going to give us the value of what? The profit. Exactly. That is what we are looking for. But not now. We have to write a few more lines because we are not visualizing right now. So because we are not visualizing, we are going to do a few more steps just to make sure that we have a column where we are able to visualize our or compare what we have done. Okay. So the Y prediction, the line would be the same as that, but we are going to use one thing, um, print options. I guess it was set print options. Yeah, it was set print options. Okay, so we are going to use NumPy to make sure that we are able to, visualize or compare the data in a way. We are not visualizing, we are comparing it, and we are comparing it in a way so that we have our test set results here one at one side, the original data at one side, and then we have our predicted data on one side. Okay, let us do that. So, and we are going to do one thing. We are going to set the precision to 2 decimal points. So what does this line means? That because see, you have sometimes you have many decimal points. Just to make our data look good, we're going to have only 2 decimal points. Okay. All right. So the next thing that we are going to do is we are going to print something. What are we going to print? Not yet, because this is going to get a bit messy because we are going to have a lot of parentheses. So just to make sure, we're going to add print later. So there is a there is a function or method from NumPy which is concatenate. Now we have two different arrays with us. The original array that we are going to uh, compare it through, which means y test, and then the value of x test. So the x test is giving us what? Tell me. Yes, it's giving us the value of the predicted data. Now, the y test was the actual data. So, if this is the x test value, the original value of uh, the original profit of this column was this much, right? Now, but what we are going to do right now is that we are going to get a value that is being predicted by our model, and now we are going to compare it with our y test model, which was the original value. So now what we are doing is we are comparing our original from the predicted value. I hope you get that. If you do not get that, comment down below, and I'll make sure to explain that again in a short video. Okay. So np.concatenate. Now concatenate is a function that is why we are is a class of functions maybe. So that's what we are going to print here. But if we look at concatenate right here, we'll see this, what does it take? So concatenate takes join a sequence of arrays. So it's taking another bracket and then axis. Okay, so it need another bracket. Okay, that's what I'm going to do. And then we're going to give it arrays, right? So concatenate does two things. It either helps you visualize or compare things, concatenates horizontally or vertically, vertically or horizontally. So if you look at this one, this is horizontally done. So these are two arrays, but these are horizontally given to us. But we want vertical, so it's easier for us to look at it, right? So what are we going to, you know, what are the two arrays that we are going to use? Well, the first one is y test and second one is y pred. So let's use the y pred one first. So y pred would be the first one. Then we are going to use the reshape. Now, why reshape? Well, it's a numpy function which helps us to tell the print options that we want it horizontal, we want it vertically set so that we can actually visualize it. All right, so it's ypred dot reshape, and then reshape would is again a function. Now, how do we want to reshape it? Well, the reshape would be done through the length of ypred. I'll explain what this means, and then the column would be y. Okay, let me explain what this means. So we are concatenating, which means we are adding two arrays horizontally. That is what our intuition is. But now, which one is the first array? Ypred is the first array, and we are using dot reshape function of the numpy, which is allowing us to concatenate in a way where this would allow us to put two arrays side by side and help us compare it, right? So that is what we are going to do. So reshape is, that is what reshape gives us. And both of these, if you look at concatenate, both of these should be of the same size, right? So both of these should be of the same size, because of which we are using reshape, and this reshape tells us that the rows should be of the length of ypred, that how long ypred is, and there would be only one column. So one column of this and one column of the secondary that we are using. All right. So this is for the first 10, and then we are going to use a comma again. And mind you, why we are using that. So I'm just going to copy this. I'm going to paste it here. And then we are just going to change y pred to y test, because that's our second column that we want to compare, right? Okay. So this is what it is, y test, and then everything is good. But there's this one more thing that we need to add, right? If you look at it, there's one more thing that we need to add, because so if you look at it now, um, this this function that we were using, it had one more part where we needed to add axis. Like if you look at concatenate right now, so I'm not sure why it's not loading up. But if you look at concatenate, it was asking us for A1 and A2, and then it was asking us for axis. But this axis should also be given, which means how do we want it? We want it vertically or horizontally. So we want to give it that as well as our last step. So we are going to give it as comma and 1. Now we do not need to provide it with, okay, this is what, yeah, this is what I was looking for. So if you look at it, this is, we need to give it an axis as well. So comma and an axis. So we do not need to write axis because it is a sequence, so that is okay, right? So this is there. I am hoping I've not made any mistakes here. So I'm just going to print it. Let us see what we are getting. I have put it a mistake. Same number of dimensions, index 0 has 2 dimensions, and the array next to has 0 dimensions. Okay. I have made a mistake here. Okay. I am just going to debug this. All right, so I was able to do that. It took me a minute or so, but I finally understood what was my mistake. So first of all, I had to give a print statement. Remember that I was giving at the first time, but I thought I would add it later. This was the first thing. Secondly, I this would had to be after this bracket because this is when it ends. So this colors would help you understand when which one ends. So concatenate is this is how where it started, and then a comma and then one is what the axis ends, and this bracket is where for concatenate ends, and this bracket is for print. So now I have solved that, and this is the value that we are getting now. Now, the first one is the Y prediction. This is the predicted value, and this is the actual value. So 114664 as opposed to the original value, which was 105008. It's a good prediction, but not perfect. 90593, the predicted one, 96479, the original one. Okay, quite good. 75692, 78239. Okay, still close. So these are the predicted values for us. See, this is quite close as well. So some are very close, some are not. But this is what regression is. It gives you some values which are almost l- close to what you are going to predict. But yes, we have created a model. Now you know how to create a multiple linear regression model. Okay, so what I want from you now is, let us visualize this in scatter plot. So how would you visualize this? How would you do that? And I would love to have your input on that. And if we can really visualize this or not, and if we were to visualize this, what are the different steps you would take? If it will be scatter plot or some other ways, what are the different things that you can do here? So I would love your input on that. If you could really do that for us, then amazing. So now, one more step here, actually two. So now that we have created a model for us, what if we wanted to, everything is working, yeah. So what if we wanted to predict it for a single value, just like we did in linear regression, simple linear regression? All right, let's do it. So what we are going to do is the same thing actually. Regressor dot all right, before this, let us know what we are going to do. Okay, all right, so what we need to do is we need to make a single prediction. We need to make a single prediction for profit of a startup with R&D of with R&D spend of, for example, let's give it 1,80,000, 1,80,000. And what was the next one? Let me check. R&D, administration, and marketing. Admin spend of let us give it 1,20,000, and marketing spend of 1,10,000. Marketing should, let us keep it at a higher end, 2 lakh. And state is Florida. Okay, that is given. Single prediction for this part. Okay, let us see how this would span out. So we're going to print something. What we are going to print, the object, and we are going to use a method called predict. Now, if you look at it, we are going to provide it the x value, right? The y is what it will give us back. So how was x given to us, right? How was it given to us? Let us see that. Okay, let me just remove this. Okay, so 100 was what? Let me check. Let us compare it from here. Okay, so New York was 001, California was 100 and Florida was 010. All right. So this is what it was. So I am going to first give it. So remember 2D array. So I'm going to first give it the state that I am looking for, because remember our X train first has the state, then has the R&D, then the marketing, and then the R&D, then the admin, and then the marketing. So I'm going to first give it the state. So the state of Florida, Florida has the value of, let me check again, Florida. So Florida has 010, 010. Okay. And then the R&D spend, that was, what did we keep it? 1,80,000. Admin spend as 1,20,000. And a marketing spend of 2 lakh, right? Let us print this. Sorry about this. Okay. Let us print this. Okay, so this is the profit that the company or a startup should be having if the R&D spend they have is this much, admin spend they have is this much, and the marketing spend they have is this much, and the state they are in is Florida. So what if I just change the state? I can do that, right? So let me make it 100. Does it make a difference? It does. A small difference, but it does make a difference. What if it was 0, 1, this was the same, 0, 0, and 1. Does it make a difference? Yes, it does make a difference. Small, but it does. So this is how you understand how a multiple linear regression model actually works. Now this was for the single prediction. All right. So thank you so much for watching this video. I'll meet you in the next video where we'll be talking about polynomial regression. Thank you everyone, and see you in the next video.